All right. So as you can see, I want you to create a table of values. So I'm just going to use these 5 values. You can see the long, hard, ugly way of doing things is you're going to plug in to find f of 2. You're going to plug in -2 for each of those and find this value. All right. So of course on the next one I'm going to plug in a -1 into each of these. And what do you end up getting? -8. All right. I'll trust your answers on those. Bless you. You plug in a 0 right here. Sorry, that was a 1, -1. When you plug in a 0, I want you to watch something really cool that happens. Remember, I talked about this anyways, about the constant being the y-intercept. Y-intercepts always happen on the y-axis, right? So x is always 0. So this should be my y-intercept, right? Well, doesn't that turn into 0? 0, that's a 0. That should have been, oh, come on. 0, 0, 0. What are you left with? -3. See, that always happens on those polynomials, okay? Anyways, what do you get for the other 2? We'll go through them quickly. When you plug in a 1, you get a... When you plug in a 1, you get a 2, don't you?
Yes.
Okay. And when you plug in a 2, you get a 7? All right. And that's all I asked you to do. Now, I didn't ask you to graph these, but I'll help you graph them right now because I didn't tell you to put it on graph paper. But if we graph these, obviously on my particular scale, -2, -61, it's off my paper. I'm not going to mess with it. But -1, -8, let's see, where am I? 1, 2, 3, 4, 5. I can't count carefully. What I want to do is I want to kind of look at this real quick. If I were to graph this polynomial based off of this table of values, I get what appears to be, what would you call that last year? Looks pretty close to a line, doesn't it? Kind of hard. Well, what do we know about lines? Lines are, yes, all lines are straight. Lines have a constant rate of change, don't they? Also known as a slope. Could I count the slope and figure this out? So watch, I'm just going to start here. I'm going to count up 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5. Hey, that's a slope of 5. That's a dead straight line, isn't it?
Yes.
But look at the equation. Is this a line? What should this be? This should be, we know it's quartic. We've already got experience with this. We know that this is negative, so we know that the 2 ends face like this, and we know it looks either like a U or maybe it does a little dance up top, right? But it is most certainly not a line, right? That's the problem with the table of values and polynomial functions, is there's so many little things that happen in the middle of all these computations that you actually miss out on it, okay? I didn't ask you to do this, but can somebody do 3 for me? I actually have it up here on the calculator.
I thought that 2.
If I plug in a 3, I get -36. Okay? And I didn't ask you to do that. But look for a second. If I went up in a straight line, straight line, straight line, straight line, and then I jumped down to -36, is that a straight line? So most definitely something weird is happening, right? What I really want you to focus on is the fact that it's hard to tell off a table of values, but there are some things that we do know. For example, right here, I was negative, 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 but it's getting bigger, right? And then what happened in between 0 and 1? It switched from negative to positive. So what has to happen between 0 and 1? I have to have what? A root, a solution, an x-intercept. Remember all those words are the same? So I have a root somewhere in between there. I don't know what exactly, but I know it's somewhere between there. Is there another root somewhere hidden? Between 2 and 3, there's another root, isn't there? Okay? And what you cannot tell on this graph is you cannot tell that it looks like this. Straight up, and then there's a little wiggle right here. And then it goes straight up, and then hard down all the way to 36. You can't tell that on a table of values, okay? But I wanted you to do the table of values for 2 reasons. One is to see how deceptive it can be when you're only dealing with integers. And 2, so you didn't miss out on the magic of everything that's going on, all right? If I were to put in fractions into all this stuff, I would end up finding this little curve right here. If I put in -1/2, you'd see how the fractions start happening, okay? All right. That's just kind of, in my calculator I've graphed this and it looks something like this. It looks pretty close to that 0 mark, so I'm going to make sure I get that. But it comes up and down and around like this. Does that look about what you have in your calculator? Okay. Now I'm just looking for a sketch, so we're not on graph paper. But I do want to indicate all of these things on this picture somewhere. Okay? So I put the roots first. They're normally one of the most important things about it. So I remind you how to find the roots. So Jacob, run the calculator for me. You're going to go second trace, number 2 zeros. Okay, and look on the screen there. You see where it says number 2 is 0, right? Now I'm going to pause this and talk about it, but go ahead. See how it says left bound? What he wants to do is he wants to move the cursor so that it's to the left of the 0, so somewhere over here. So go ahead. All right, that's fine. And he'll press enter. Well, wait, before you press enter. No, go ahead, press enter. All right, notice the y value on his screen is negative. It says negative 2.6, but it's negative something, right? When does the next 0 happen? After it turns to positive. It has to happen. So he's going to move to the right, and he's just going to watch it until it turns to something positive. And he's clearly positive now because now he's right here. So now he's at positive 2. So if he presses enter again, and on his calculator screen, it gives you these two little things right here. Well, what it's telling you is that if you're in between these two, it's going to find the 0. All right? So that's what the calculator screen looks like. If he presses enter, it should tell him what it is. And what does it say? It says he has a 0 at negative 2.77. So we'll just round that, and we'll say that's negative 2.8. So that 0 happens at about negative 2.8. So that was just one of them. I need to do the same thing over here. It looks like it might be a 0, but it's only one way to know for sure. So we're going to move over here and do the same thing again. This time, I'm going to try to set up these little arrows to happen in between here and here. And that 0 should happen right in between there. So go ahead and slide it over. Right now he's positive. No, actually, back up a little bit. He's positive now, right? And when he switches, go ahead and press enter. And then when he switches to negative, he'll know that he crossed the 0 somewhere, didn't he? So that's a good indication. So he needs to move until he switches to negative. That's fine. Presses enter, and it should give him the answer of, go ahead. It says negative 0.48, so we'll round that to negative 0.5. So it looked like it was 0, but it really wasn't. It was negative 0.5. It was just a little bit to the left of 0, wasn't it? I've got one more 0. Do it again. Same process. Same process. So come find this one. So you want to set these things up so those two arrows are in between. That way it falls in between. You want to get to the left. Start. This time you're going up, so you're going to start negative. Press enter. And then switch when you get to positives.
I've got the positive.
So you'll have to just do it again. If you do it too early. But if we do this correctly, it should be something like, oh, don't do that. What did we say? 2.3. All right, so those are the zeros. All right, check. Now I'm going to switch colors. We need to find something else. Can anybody tell me any of these other?
Y-intercept.
Okay, we want to skip to y-intercept? That's fine. What's the y-intercept?
-3.
Okay, up here's the y-intercept. So that's going to be -3. So just go to your graph and find -3. I do not have a very good graph. It should have crossed down here at -3. Okay, so I probably should have drawn this down a little bit further and made it a little more clear. Okay, it's going to be hard to fix that now. But I should have gone down this and made this a little bit more clear. So my graph really should have gone down here a little bit more. Okay, so I'll make that adjustment. All right, so I got my y-intercept. What else?
End behaviors.
Okay, you know the end behaviors. You aren't avoiding the relative maximum because you don't know what it is, right? Let's handle it while I still got space, okay? The relative min and the max up here, I've given you the calculator for it. What does it mean to have a minimum or a maximum value? So, the maximum value, if you're local, you are a relative, you are close by. The relative maximum or the local maximum is this hill right here. It's not the biggest on the entire graph, but it's the biggest nearby. And the local minimum is this little valley down here. It's not the lowest on the entire graph, but it is the lowest nearby. So what we're going to do is we're going to use these buttons. So again, we're at second trace. We're going to find min and max. So let me use this color here. So my local maximum is going to be this point right here. So I'm looking for a point. So go ahead and, we'll turn it back. Okay. So just using the calculator, you found out it was negative 1 point. That's too sloppy. It's negative 1.7 and positive, I'm sorry, 1.8. I rounded wrong. And 5.2. So it's not the overall maximum, but it's a local maximum. And now the local minimum would be this point on the bottom of the valley. So again, use your calculator. Let's see, you've got negative 1.1 and negative 7.0. And you would want to put 0.0 there because that's clearly not exactly 7, right? So that's fine. All right, check. We got our local max and mins. Yes, ma'am.
Isn't that useful?
I will fix that on video, and I'll say that Lindsay corrected me. All right. So from last night, we remember our end behaviors are going to look something like this. So as x goes positive and x goes negative, I'm just going to use my graph here, and I'm just going to put it right on my graph. Anybody has any objections to that? So right here, I'm going to say x approaches positive infinity. When x is going to positive infinity, what's happening to the y's?
Going up.
Aren't they also going up? These are going up, 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 up. So they're also going to positive infinity. So y goes to positive infinity. There's one end. Now look on the other side to get the other end. As my x's go negative, the further I go negative on my x's, my y's go lower and lower negative also, don't they? So my y's approach negative infinity. There's my end behaviors. And so check, I got those. Now I've got domain and range. On this particular problem, the domain would be what? What kind of values can I choose for this graph? I can choose anything in the world. My domain are going to be my x's such that x is, that was wrong, sorry, an element of all the real numbers. It's all real numbers for x. What about my y's though? As I pick any number in the world for my x's, what kind of y's do I get out? I get all of them again, don't I? Because these go forever up and these go forever down. I get them all. So my y's are also all real numbers. Now, does that happen on every one? No, it doesn't. Okay? If you would have had a even function, it wouldn't be all real numbers, would it? Because isn't there a maximum and a minimum, or a minimum on an even function? All right. Questions? Yes, sir.
Can you give the domain again?